This module describes the AWG instrument, which is the software interface to the arbitrary waveform generator in SmartTest 8. Although the main implementation of the AWG instrument is within WaveScaleMX, it also applies to a few other V93000 cards, such as AVI64. The main focus of this training, however, will be on WaveScaleMX.
The AWG instrument is an abstract, logical measurement instrument which is supported by various test head cards. The focus of this training is the WaveScaleMX card. As a result, the AWG settings use the same properties or commands, independently of the underlying hardware. You find AWG settings in the AWG setup, the source waveform action, and the waveform. Of course, the absolute capabilities of the card must be considered. The DUT board description assigns signals to pogo connectors. The input impedance of a DUT pin or a DUT board component is also set up here. AC and DC input impedance can be set separately as shown in this example. The default AC impedance is the value of the DC impedance. The default DC impedance is high impedance, which is 1 megaohm. The default view is the source view, which is available on the last tab, but you can edit in any one of these tabs and all of the other views will be updated instantly. Notice the multiple tabs on the bottom of the editor view, when viewing the DUT board file. Here you see the AC and DC input impedances properties in tabular view. The Signal tab of the Setup editor lets you do the pogo pin assignments to every signal in tabular view. At the highest level, the AWG instrument has property groups, actions, options, and states. All of these can be set and modified. Some are allowed to be changed within an operating sequence execution, while others must remain fixed for the duration of the operating sequence execution. Now click the buttons to see the respective properties. The instrument group defines the setup parameters of an instrument. It is part of the specification file. All of these properties have default values and thus are optional. You can scroll the table vertically. These settings must also remain fixed for the duration of the operating sequence execution. Keep alive is an important property. If set to true, the instrument stays locked and keeps sourcing a continuous waveform, or the last sample, in case of a non-continuous waveform. In this case, the instrument is not available for further measurements and the configuration cannot be changed, unless the flag is explicitly cleared, or the channel is disconnected. Keep alive is required to be set to true when debugging with external instruments at a breakpoint. This table summarizes the option settings of the AWG instrument. Options apply to all actions within a specification and cannot be changed during a measurement or operating sequence execution. The source waveform action is the only available action for the AWG instrument. The table below lists the action properties. They are set in the action section of the specification file. Scroll the table down to see all available action properties, descriptions, and default values. The DUT board group defines the setup parameters of the DUT board. It is specified in the DUT board file. These settings remain fixed for the duration of an operating sequence execution. The properties are summarized in this table. States are available for viewing at a breakpoint in the measurement view, or can be queried from within the Java code using getter methods. States cannot be set. Instrument properties can be set in various ways. One way is to directly change the settings in the source code of the specification file. Alternatively, you can use the setup editor or the measurement view to edit the properties in a table. On the last screen you see the AWG instrument represented in the instrument view. Click the blue interaction buttons to see the full windows. There are different ways to connect device pins or load board traces to the WaveScaleMX AWG instrument. They can be as simple as a single-ended connection or as resourceful as using both positive and negative legs of the AWG output to drive the device. Note that in this case, the signals on the positive and negative legs will be 180 degrees out of phase with each other. As long as this does not adversely impact the application, it is a suitable approach. Here's a quick list of practical notes that you should keep in mind when working with the AWG instrument. Here's a quick list of practical notes that you should keep in mind when working with the AWG instrument. It is very important to understand the difference between keep alive and repeat infinite. Keep alive keeps the AWG running throughout many test suites. It is used to keep, for example, a PLL running, or keep it synchronized with other resources throughout larger blocks of the test program. Those blocks would otherwise have to resynchronize in every test suite. Repeat infinite is a convenience feature that keeps the AWG running during a certain measurement, so you do not have to compute and adapt the number of repetitions. If keep alive is set to true, the instrument is locked and keeps its state. If it is sourcing an infinite waveform, it keeps sourcing this waveform. If the waveform is not infinite, it just keeps sourcing the last sample. This means that both repeat infinite and keep alive have to be set to true to keep a periodic waveform running throughout several test suites. Keep alive is also required if you're using an external scope or spectrum analyzer. While the instrument is locked, it is not available for further actions. The configuration cannot be changed unless keep alive is explicitly set to false. And here are some additional notes on maintaining high accuracy. There are measurements that require high synchronization accuracy. For example, in an IQ measurement, where a pair of the AWG instrument channels need to source the I and Q analog waveforms with high synchronization accuracy. In this case, you have to disable the instrument upsampling by setting the upsampling property of the source waveform action to off. Because when upsampling is enabled, Smart Test will use hardware interpolation, which does not guarantee the same accuracy as when upsampling is disabled. If higher sample rates are required in a measurement, the waveform specification itself needs to be designed for the required sample rate. Thus, upsampling in the instrument will not be required, and at the same time the requirements for synchronization and alias suppression can be fulfilled. Tests using the AWG instrument can also be set up with Java code, using the DS API. This is done in the setup section of the test method code. All instrument properties, the waveform, the action properties, and the operating sequence, can be set and queried with dedicated functions. Click on the Expand button to get a detailed view of the relevant code snippets.
These are the key things to remember from this module.